In this lesson, we're going to be focusing on three different calculations involving and describing the concentration of solutions. All right, concentration measures the amount of substance per unit volume. So if we say that we have a concentrated solution, it's relatively strong. We have a lot of solute that's been dissolved into a solvent. If it's diluted, it's relatively weak. We have very little solute dissolved into a solvent ratio. One important thing that you have to remember from an earlier topic is that your solution amount is equal to your solute plus your solvent. And you're going to see that come up when we go to do these calculations. All right, so we're going to get started with these formulas. All these formulas are basically on the back of your reference table. So the first one is parts per million. The concentrations of very dilute solutions are often expressed in parts per million, or ppb. We technically have even parts per billion for even tinier amounts, but we don't have to worry about that. This formula is on the back of the reference table. You can see specifically, you put the mass of your solute over the mass of the total solution, and you times it by 10 to the 6, or by a million. So here's our first practice problem. We have 0.0047 grams of ammonia that are dissolved in 20 grams of water. We need to express this concentration in parts per million. So we are going to use this formula that we showed before. Now, one thing is while we have the mass of the solute, which is the mass of the ammonia, the solution has to be both the water and the ammonia. So we're going to add those together, and that's going to be the mass of my entire solution. So then we're going to plug in our 0.0047 for the numerator, mass of the solute, and 20.0047 for the mass of the solution. And when we calculate that, we get 235 parts per million, which means if I have a million particles, 235 of them will be ammonia, the rest are going to be water. All right, our next one is percent by mass. This is also on the back of your reference table. Just keep note that either these both need to be in grams or both need to be in kilograms, as long as they're in the same unit. All right, so for the practice problem for percent by mass, it says what is the percent by mass of a solution containing 12.3 grams of caffeine dissolved in 100 grams of water. So looking at our formula, while that caffeine is our solute, our solution has to be both the water and the caffeine. So we need to add those together to get 112.3 for my solution. Then we go ahead and plug in the 12.3 grams on top, the 112.3 grams on the bottom, and when we calculate that, we get 11%. So 11% of the mass of my solution would be from caffeine. Now, percent by volume isn't directly on your reference table, but we're going to use the previous formula, which is percent by mass, and simply, instead of using masses, we're just plugging them in as volumes. It's still solute over solution. So for this practice problem, it says, what is the percent by volume of a solution containing 18.2 milliliters of glycerin dissolved in 85.0 milliliters of water? So again, we're going to be using solute over solution. Now, one thing I do want to know is all these examples have a separate mass of water, but tomorrow, or in class, I am going to show you what happens when they actually do give you the total solution and the wording of that and how that's going to look for you. So let's go back to this. We know our solute is going to be 18.2, but our solution has to be both the water and the solute. So we're going to have to add them together again. Go ahead and plug them in, 18.2 over the total mass of both, and we get 17.6%. So in the volume of my container, 17.6% of it would be attributed to the glycerin. Okay, so again, just remember one key part of this is that knowing the amount of solution equals the sum of the solute and the solvent depending on the wording of the question. And we'll practice this more in class.